Hey guys, Anna here. Today we're going to be talking about plate tectonics. So, plate tectonics is a theory that the outer ridge layer of the Earth is divided into dozens of plates that slide across the Earth's surface relative to each other. The Earth consists of plates and plate boundaries, the zones where the plates contact and interact. We see the Earth as fixed and stable and rigid, not moving. But in reality, they're moving at a constant speed really slowly, about 6 inches per year at the most. Earth is made of 7 major plates: the African, Antarctic, North American, South American, India, Australian, and Pacific plates. There's also a lot of smaller plates scattered all around the Earth that are much smaller than these major plates, but there's still a lot of activity that goes on over there. The lithosphere is the land that is moving on the Earth's surface. It's made of the Earth's crust and part of the mantle. Now we're going to be talking about a scientist who played a major part in the theory of plate tectonics. He came up with a theory called continental drift. His name is Alfred Wegener. Alfred Lothar Wegener was born on November 1st in 1980 and died in November 1930 at some point. He was a German polar researcher and geophysicist and meteorologist. He was the first scientist to propose the continental drift theory in the earliest 20th century about. Basically, his hypothesis claimed that all of the continents and all of these continents that we see today, all of the 7 that we know, were all connected at one point on Earth, creating one giant supercontinent called Pangaea. He was really criticized for this. People thought that he was insane. They didn't think that it made any sense. He was basically made fun of his entire life up until the point that he died, and nobody really accepted that theory up until like the 30s, in the 1930s. It was like a posthumous theory, so it only came into play after he died, which was quite sad, I think, because he was brilliant and lots of people looked up to him, but they thought he was kind of crazy. The next thing we're going to be talking about is called paleomagnetism. What is paleomagnetism? Well, paleomagnetism is the study of the record of the Earth's magnetic field in rocks, sediment, or archaeological matters. Scientists can study the Earth's history by looking at Earth's magnetic field and using Earth's rocks as records. Paleomagnetism is the study of magnetic rocks and sediments to record the history of the magnetic field. Some rocks and materials contain minerals that respond to magnetic fields. So when rocks form, the minerals align with the magnetic field, preserving its position. It's called rock magnetism when rocks record the position of the magnetic field. The magnetic signature of the rock allows paleomagneticists to date the rocks and map the position of the field in their time and in their information. Paleomagnetism is one of the strongest pieces of evidence for the theory of plate tectonics that we have to date. The evidence has shown that some rocks in Alaska have magnetic materials organized in the same way that they would be found near the equator. This shows that over time the rocks must have changed position. Paleomagnetism helps prove how the continents used to be matched up like a puzzle. We were talking earlier about the supercontinent called Pangaea. The orientation of minerals on the coast of South America strongly resembles those on the coast of Africa. This evidence helps prove that they must have been one large landmass at some point. So basically, to recap everything that we talked about today, we talked about the theory of plate tectonics, and we talked about how there are multiple layers of the Earth divided into dozens of plates that slide across the Earth's surface. These plates we used to think were rigid and that the Earth didn't move at all, but we found out that it moves slowly 6 inches per year, and that there are a total of 20 plates, and there are 7 major plates resembling each one of the continents, respectively. We also learned about Alfred Wegener and his theory of continental drift. He was the main scientist who proposed this theory, and it's one of the biggest theories still holding in today about tectonic plates and the theory surrounding that. And we learned about paleomagnetism. Paleomagnetism is one of the main sources of evidence for the entire theory of plate tectonics and continental drift, and it shows that the Earth could not have possibly been the way that it was so long ago, based off of magnetic mineral compositions and different rock fragments found in different places and puzzle pieces matching up together. It truly opens our eyes to what the world possibly could have been so long ago.